students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as network analysis. Let's see some guys. We're doing question number 16 on page 307. I'll write the sum down. Activity A, B, C, D, E, F, G, H, I, which is from 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 6, 4 to 7, 5 to 8, 6 to 8, 7 to 8, and time in days is 3, 4, 6, 5, 6, 5, 4, 7, 4, 7, 4. Right? Now, let's make the network diagram first. A, it starts from 1. So you have 1, right? I'm going to divide this to 3 parts. 1 goes into 2, 1 goes into 3, 1 goes into 4. So you have 3 outputs coming out from here. One goes into 2, 1 goes into 3, 1 goes into 4. Right? This is activity A, which is 3 days. This is activity B, which is 4 days. This is activity C, which is 6 days. Right? Now, 2 goes into 5. 2 goes to 5. Right? This is activity D, which is of 5 days. Right? 3 goes to 6. 3 goes to 6. This is E, which is 6 days. And then 4 goes to 7, which is 5 days. 4 goes to 7. And this is activity F, which is 5 days. Right? Now, 5, 6, 7, all 3 go to 8. 5, 6, 7. All 3 go to 8. This is G, which is 4 days. This is H, which is 7 days. And I is 4 days. Right? And this is my activity 8. So that is going to be my network diagram. Right? Now first, let's find out the critical path. First thing that you have to do is draw a network diagram. Next, let's see the paths. You have path ADG. You have path BEH. You have path CFI. Right? Duration. Duration is 3 plus 5 plus 4. That's 12 days. Then you have 4 plus 6 plus 7. 11, 17 days. And then you have 6 plus 5 plus 4. 15 days. Right? So in that case, the maximum duration is said to be the critical project completion time, and that path which gives you the maximum duration is the critical path. Therefore, I can say that critical path is B, E and H, and project completion time is 17 days. Okay, now let's see how we do this. Project completion time is 17 days, right? Now let's first mark the critical path out. Let us mark out the critical path. I told you that you mark the critical path with a double line. So I'm going to mark this with a double line. So this is 1. This is my critical path. My critical path is BEH. BEH. So that's my critical path, right? Now, once you know the critical path, first let's do the timing for the critical path. This activity starts at 0, ends at 0. Okay?
Now,
So you assume that it has just started. When it has started, time period is 0. It takes 4 days for B. Start time increases by 4, end time increases by 4.
so what
0
about
plus 4, 4. 0 plus 4, 4.
so what about that 3?
Which 3? First you have to work with the critical path.
Okay.
Right? Then 4 plus 6, 10. 4 plus 6, 10. 10 plus 7, 17. 10 plus 7, 17. So first thing that you do is you work out on the timing of your critical path. Okay? Now for the non-critical path, you will work only on the start time. The first time is called as the start time, the second time is called as the end time. So 0 plus 3, 3, you will work only on the start time. 3 plus 5, 8, that's it. For the end time, you will work backwards. 17 minus 4, that is 13. 13 minus 5, that is going to be 8. So that's how I'll get this. Once more, I'll show you for the other non-critical path. CFI. Start time is from starting to end. So 0 plus 6, 6. 6 plus 5, 11. For end time, you have to work from backwards. You have to work from end point to starting point. 17 minus 4, that's 13. Right? 13 minus 5, that's going to be 8. So that's how I have the time done. Right? Do we get this thing clear? So do we understand how we make this table with the timing? How do we make our network table with the timing? Now, let us see what all can I find out. Activity A, B, C, D, E, F, G, H, I. It's up to I. Right? Now, I'm going to find out everything in this summary. I'll show you how to find out. First thing that you have to find out is forward pass. Right? Now, what do I understand by forward pass? It is the calculation of earliest occurrence of time of all events. Right? Now, how do I get the forward pass for activity A? Guys, the start time. You consider the start time of all activities, that's going to be your forward pass. So for activity A, the forward pass is going to be 0, the initial one. Right? That is for 1. Right? Instead of writing this as A, B, C, D, I'll write this as 1, 2, 3, 4. That will make things more simpler for you. 1, 2, 3, 4, 5, 6, 7, 8. Now it is easier for you to identify. For 1, the start time is 0. For 2, the start time is 3. For 3, the start time is 4. For 4, the start time is 6. Right? For 5, the start time is 8. For 6, the start time is 10. The first time is the start time. For 7, the start time is 11. And for 8, the start time is 17. The start time is also called as your forward pass, or it is also called as your earliest occurrence time. Right? The next thing that you have to find out is backward pass. What do I understand by backward pass? It is the calculation of the latest occurrence of all time. Right? Now, backward pass, I'm going to move from behind up. Backward pass means I have to take end time. Right? Now, end time for this is 17. For event 8 is 17. Right? N time for event 7. N time for event 7 is 13. N time for event 6. N time for event 6 is 10. Right? N time for event 5. End time for event 5 is 13. Right? Do we get this thing here? End time for event 4 is 8. End time for event 3 is 4. End time for event 2 is 8. And for 1 is 0. So that's how you get your forward pass and backward form. Fine, do we get this thing here? Okay, so now that we know how to get forward pass, backward pass, now let us see some more calculations for this. The next thing that you could find out using this table is, let's consider activity A, B, C, D, E, F, G, H, I. This is your 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 6, 4 to 7, 5 to 8, 6 to 8, and 7 to 8. Right? Now before I explain more things to you, I'm going to explain a particular diagram that will enable you to understand how to solve those things that I'm going to explain. Right? If you have two activities, how are they symbolically represented? I'm going to explain to you the symbolic representation of two events and two activities. We will call the first event as I, we will call the second event as J. Right? Hence, the time here will be, say, this event is going to be IJ. The activity is going to be IJ. We call this as EI and we call this as LI. Right? Earliest start time, latest start time. This is going to be EJ, earliest finish time and latest finish time, LJ. And the time is written as TIJ. Right? If you understood, on the basis of this, I'm going to explain a couple of formulas to you now. Right? Let's see how do we solve this. How do I find out earliest start time? Earliest start time is given by the formula EI. That means out of the two circles that you will have, first circle, first time will be your earliest start time. So now, let's look at the network diagram and let's find out which is our earliest start time. The earliest start time for activity A will be 0. Right? For activity B will again be 0. Right? For activity C will again be 0. For activity D will be 3. For activity 3, the earliest start time is going to be 3. For activity E, the earliest start time is going to be 4. For activity F, the earliest start time is going to be 6. For activity G, the earliest start time is going to be 8. For H, earliest start time is going to be 10. And for I, the earliest start time is going to be 11. Very simple. Right? The earliest start time. Then, the next thing that you have to find out is earliest finish time. Earliest finish time is nothing but start time. Earliest start time plus Tij. Right? Guys, symbolically let's understand this. This is earliest start time plus Tij. This plus this will give you earliest finish time. Right? So, for activity A, it is going to be 0 plus 3. I will write that way so that you know how I am getting this. This is going to be 0 plus 3, that is 3. Right? For activity B, it is going to be 0 plus 4. For activity C, it is going to be 0 plus 6. For activity D, it is going to be 3 plus 5. For activity E, it is going to be 4 plus 6. For activity F, it is going to be 6 plus 5. For G, it is going to be 8 plus 4. For H, it is going to be 10 plus 7. For I, it is going to be 11 plus 4. That's how you find out earliest finish time. Next, latest start time. Right? Latest start time is nothing but your latest finish minus Tij. First, let's find out latest finish time. Latest finish time is nothing but Lj. Guys, symbolically let us see this. If this is the symbol, latest finish time is this number. Okay? Of the second circle, the last number. Right? So, for activity A, the latest finish time is going to be 8. For activity B, the latest finish time is going to be 4. For activity C, the latest finish time is going to be 8. For activity D, the latest finish time is going to be 13. For activity E, the latest finish time is going to be 10. For activity F, the latest finish time is going to be 13. For activity G, the latest finish time is going to be 17. For G, the latest finish time is going to be 17. For H, also the latest finish time is 17. For I, also the latest finish time is 17. Fine, do we get this thing here? So that's my latest finish time. Now let us find out latest start time is nothing but latest finish minus Tij. Let's symbolically first understand this. Latest finish minus Tij. Okay. So for activity A, guys, for activity A, it is going to be 8 minus 3. For activity A, it is going to be 8 minus 3, which is 5. For activity B, it is going to be 4 minus 4, which is 0. For activity C, it is going to be 8 minus 6. 8 minus 6, 2. For activity D, it is going to be 13 minus 5. 13 minus 5, that is 8. For activity E, it is going to be 10 minus 6. 4. For activity F, it is going to be 13 minus 5. Right? For activity G, it is going to be 17 minus 4. For activity H, it is going to be 17 minus 7. For activity I, it is 17 minus 4. That is 30. So now we know exactly how to find out start and finish time. The earliest start time and the latest start time. Similarly, the earliest finish time and the latest finish time. The next thing that you have to find out is float. Now first of all, what do I understand by float? Float means the amount of time by which the completion of an activity can be delayed without delaying the total project completion time. Right? For example, this is, guys, let's see the network diagram. This is say 4 days. By how many days can I delay this activity and yet finish my work in 17 days? That is called as float. By how many days or by how much time can I delay an activity without affecting the total project completion time? That is called as float. Right? See, by how much time can I delay this activity? So instead of 4 days, if I take this as 6 days, and yet if I can finish my project in 17 days, then that is called, how many days did I delay activity B? 2 days. So that is the float for activity B. By how many days can I delay each activity and yet complete my project in time? That is called as float. Fine, do we understand this? Now we have different types of floats. Let's make a separate table for floats. Let's put all the different types of floats in one table. A, B, C, D, E, F, G, H, I. 1, 2, 1, 3, 1, 4, 2, 5, 3, 6. B6, 4, 7, 5, 8, 6, 8, 7, 8. Now that we know what is a float, let us try to find out total. Let's find out different types of floats. The first type of float that you have is called as total float. Right? Now, what do I understand by total float? It is the amount of time by which the completion of an activity can be delayed beyond the earliest possible finishing time without affecting the total project completion time. Right? The earliest time, by how much time can it be delayed and yet my project can be completed in time, that is called as total float. Now how do I find out total float? Guys, total float can be written as latest start time minus earliest start time. Right? We have already found this out in the previous table. Latest start time and earliest start time. If you subtract the two, what you get is float. You have multiple formulas to calculate total float. I could also calculate using this. I'll show you another formula also. I could find out total float by using the formula. If I have to use just this table, Lj minus Ei minus Tij. Lj minus Ei minus Tij. So if I have to just find it out directly from the network diagram without calculating the start and finish time, then this is how I will find out float. Let's try to find out the float, guys. For activity A, it is going to be 4, where's it gone? Sorry, it is going to be 8 minus 0 minus 3. 8 minus 0 minus 3, that is 5. For activity B, it will be 4 minus 0 minus 4. 4 minus 0 minus 4, 0. For activity C, 8 minus 0 minus 6, 8 minus 0 minus 6, 2. For activity D, it is going to be 13 minus 3 minus 5, 13 minus 3 minus 5, that will be 5. For activity E, it is going to be 10 minus 4 minus 6, 10 minus 4 minus 6, 0. Then F can be written as 13 minus 6 minus 5, 13 minus 6 minus 5, 2. Next, for G, 17 minus 8 minus 4. How? 12. 5. Fine, do we get this in clear? Next, I could also say for H it will be 17 minus 10 minus 7. 17 minus 10 minus 7, 0. And for activity I, it will be 17 minus 11 minus 4. 17 minus 11 minus 4, 2. So these are the number of days by which these activities can be delayed beyond their start time and yet you could complete your project in time. Right? So that is called as total float. Next, let's find out next kind of float, which is called as free float. What do I understand by free float? It is the amount of time by which the completion of an activity can be delayed beyond the earliest finishing time. I have to finish an activity in say 6 days. By how many more days can I delay it and yet finish my project in time? That is called as free float. Free float is given by the formula Ej minus Ei, Ej minus Ei minus Tij. Ej minus Ei minus Tij. Right? Let's try to check this. For activity 1, 3 minus 0 minus 3. 3 minus 0 minus 3. That's 0. For B, 4 minus 0 minus 4, which is 0. For
So,
activity,
इसको भी दो फॉर्मूला है.
yes, I will give you multiple form. I'll give you all the formulas.
Okay.
Right now, I'm just giving you formulas based on this particular diagram, symbolic diagram, so that you can calculate from network and you don't need any other table. Right? For activity C, it is 6 minus 0 minus 6. 6 minus 0 minus 6, 0. For activity D, it is 8 minus 3 minus 5.
0.
For activity E, 10 minus 4 minus 6.
0.
For activity F, 11 minus 6 minus 5. For activity G, 17 minus 8 minus 4. 17 minus 8 minus 4.
5.
Right? Then for activity H, this is going to be 17 minus 10 minus 7. 17 minus 10 minus 7. And for activity I, 17 minus 11 minus 4. 17 minus 11 minus 4. 2. That's my free float. Right? Next, the next kind of float that you have is called as independent float. Right? Now, independent float, it is the amount of time by which the start of an activity can be delayed without affecting the earliest start of subsequent activity. Here I am not talking about project completion time, but I am talking about the earliest start of subsequent activity. Now, independent float is given by the formula Ej minus Li, Ej minus Li minus Tij. Right? So, symbolically it is Ej minus Li minus Tij. Right? So, let's try to calculate this, guys. For activity A, Ej minus Li minus Tij. Right? So, this will be 3 minus 0 minus 3. 3 minus 0 minus 3 is 0. For activity B, 4 minus 0 minus 4. 4 minus 0 minus 4, 0. For activity C, 6 minus 0 minus 6.
0.
For activity D, 8 minus 8 minus 5. 8 minus 8 minus 5, minus 5. For activity D, for activity E, 10 minus 4 minus 6. 10 minus 4 minus 6. For activity F, 11 minus 8 minus 5. 2. For activity G, 17 minus 13 minus 4. 17 minus 13 minus 4. 0. 17 minus 10 minus 7.
0.
And this is 17 minus 13 minus 4.
0.
That's my independent float, right? The last thing that you have to find out is interfering float. Right? What do we understand by what do we understand by interfering float? Interfering float is a part of the total float which reduces the float of subsequent activity. Right? It is the amount of time by which the earliest possible start of subsequent activity will be delayed if the activity ij finishes on latest finish time. So by how much time will the subsequent activity be delayed? That is called as interfering float. Sorry, it is given by Lj minus Ej. It is Lj minus Ej, right? Lj minus Ej, right? So let's see for activity A. For activity A, this is going to be 8 minus 3. Next, for activity B, it is going to be 4 minus 4. For activity C, it is going to be 8 minus 6. For activity D, it is going to be 13 minus 8. 5. For activity E, it is going to be 10 minus 10. For activity F, it is going to be 13 minus 11. For activity G, it is going to be 17 minus 17. H is also 17 minus 17 and I is also 17 minus 17. So those were all the different types of floats that you could find out. Besides floats and start and finish time, there's another concept that you need to know in network analysis, which is called as slack. Right? Let's try to understand what is slack. Let's try to find out slacks. First, let's write this down. Activity A, B, C, D, E, F, G, H, I. 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 6, 4 to 7, 5 to 8, 6 to 8, 7 to 8. Now, what do I understand by slack? Every activity has a tail event and a head event. Guys, let's get back to the symbol. This is called as the tail event. This is called as the head event. So every activity has a tail event and head event. Slack is associated with an event. What is slack? It is the amount of time by which an event can be delayed beyond its earliest occurrence time without affecting the total project time. In simple language, I could say that slack is how much time can it be delayed. I could have two types of slack. Either I delay my tail activity or I delay my head activity. Right? So you will have two types of slacks. One will be tail slack. How do I find out tail slack? Tail slack is going to be Li minus Ei. Symbolically, tail slack is going to be Li minus Ei. Right? So let's see. For activity A, it is going to be 0 minus 0. For activity B, also it is going to be 0 minus 0. For activity C, also it is going to be 0 minus 0. For activity D, it is going to be 8 minus 3. For activity E, it is going to be 4 minus 4. For activity F, it is going to be 8 minus 6. For activity G, it is going to be 13 minus 8. For H, it is going to be 10 minus 10. For I, it is going to be 13 minus 11. 2. That's how you get your tail slack. Right? Next, head slack. How do I get my head slack? Head slack is nothing but Lj minus Ej. Head slack is the same as interfering flow, right? So head slack is going to be same as interfering flow, Lj minus Ej, right? Now that you know how we have to calculate, let's see this. For activity A, it is going to be 8 minus 3. For activity B, it is going to be 4 minus 4. For activity C, it is going to be 8 minus 6. For activity D, it is going to be 13 minus 8. For activity E, it is going to be 10 minus 10. For activity F, it is going to be 13 minus 11. For activity G, H and I, 17 minus 17. All three will be 17 minus 17. Right? So these are all the possible timings that they can ask you for a network diagram. This finishes this topic. We'll stop this here for the day. Thank you very much.